This is Maria from Mariavis. I'd like to show you today how to create the 2D annotations in Vision 4D and how to apply the deep learning model in our software. You will see how we can do this without any knowledge in scripting. Let's start in Vision 4D. So what we see here is the transmission electron microscopy image of the brain tissue that was treated in the hypoxic conditions. Here are examples of the normal mitochondria and those which are completely swollen due to the hypoxic treatment. What we want to do here is to create the manual annotations for both mitochondrial phenotypes so that later we can train the deep learning model and segment all the mitochondria from both phenotypes at once and in the unbiased manner. By looking at the images, we can see that there are a lot of other objects which have similar intensities to the mitochondria, and that mitochondria themselves have very complex and different morphologies. In addition, there are also sample preparation artifacts, and there could be differences in the background intensity staining, which altogether makes it a complex and challenging project for image analysis. So first, for the deep learning annotations, we'll be using the manual drawing tool in Vision 4D. I can select the painting brush and immediately make the diameter smallest possible. Now I am zooming in onto the mitochondria and start painting. It is very important that the borders of the object are defined as carefully as possible because this will determine how accurate your model segmentation will be. Once I'm ready with the object, I will use the validation button here or just Ctrl-Shift-F. Let's create one more mitochondria here. And let's say I have made a mistake in my annotations and I have already validated it. So I need to select a different mouse tool to pick this object and the eraser tool to first correct the border of the mitochondria. And once I'm done, I could use again different brush radius or press Alt mouse wheel to increase the diameter and remove the rest of the false mitochondria part and again validate the object. We can use more custom shortcuts to facilitate your experience with manual drawing in Vision 4D. Now for this project, it is very important that every single mitochondria from both phenotypes is annotated on the entire section, including those objects that are visible on the section only partially. This is important because otherwise the training process will be confused by the false annotations that will be appearing in the background glass instead of the objects of interest. For this project, altogether we have taken 30 serial sections with the mitochondria images and 309 mitochondria objects across those planes. Once the model is trained and ready to use, we can import it in Vision 4D and apply it on the same or on the new images. In the pipelines in the latest Vision 4D release, we have two deep learning operators. One is for image processing, and the one that we will be going to use today is the deep learning segmenter, which allows us creating the objects in one step in the pipeline. So first we will set the scaling of the pipeline at 50%, same as it was performed during the training. Now for the deep learning segmenter, I can pick the model from the disk and upload it, and we need to do a couple of custom modifications. So we know that our training was performed on the data which is 8-bit type, which is also reflected here, as well as the overlap between the tiles, which will help to increase the accuracy of the predictions on the borders between the tiles as the model is being applied. And that's all. We can first run the preview, which has to be done at least 100% scale or more. And we see that the predictions are pretty accurate, so I can apply it on the entire section. Here are all the mitochondria, and what I have included else in the pipeline is the small filtering step to get rid of small particles, if any. And now that we have both mitochondria types, we can actually continue the analysis within the same pipeline. And here I have created the custom feature for the object, which quantifies the ratio between the intensity in the first channel and the volume of the same object for each of the objects. And we will use this to filter out the control versus the swollen mitochondria in one step. And in the following, we can export them and store the objects all at once. Now, I have also run the same pipeline on the larger number of images here, and you can see that we can also color code the objects according to their phenotype using the same ratio metric function. And in the objects table, we can access them based on the value of the feature and show the extremities of the phenotype penetration, as well as browse through all the mitochondria segmentation results and access the quality of the segmentation. So I hope this convinces you how we can do the deep learning based segmentation in Vision 4D and use additional tools in our software to apply them on your images. Thank you for watching.